Hi, welcome to IEEE TCLT expert interview. My name is Qinyu Zhao. I'm currently a master student at the Australian National University. Today, we have the privilege to have Professor Stephen J.H. Yang here with us today. Prof. Yang was the first director of the Department of Information and Technology Education of the Ministry of Education, Taiwan. And currently, he is the chair professor of the Department of Computer Science and Information Engineering and the vice president for Research and Development Office at National Central University in Taiwan. He has published more than 100 papers in international journals. In his ICCE 2019 keynote speech, Prof. Yang discussed a new concept, precision education. It is a new challenge when applying artificial intelligence, machine learning, and learning analytics to improve teaching quality and learning performance. Prof. Yang, thank you for having accepted our invitation. Today, we would like to hear your thoughts about precision education and especially the role that AI can play in education.
Yeah, thank you. It's my great pleasure to take your interview. I saw you, it's about my 2019 keynote speech in ICCE. Yeah, at that time, we talked about the precision education, kind of a new challenge to AI. So I prepared a slide, a presentation to remind me how to answer your questions, because you already it's 12 very wonderful questions beforehand, and it's very nice of you to let me know the question in advance so I can prepare for the answer. So maybe I can share my screen.
Yes, thank you. Could you share the screen now?
Yes. Question number 1.
Yeah, dear professor, could you please explain what is precision education and what are its goals and topics?
Oh, yes. As I addressed to 2019, the precision education, and you also can find from the reference below the slide. Precision education refer to we're using the AI machine learning analytics, and to improve the teaching quality. So the main concern is improve teaching quality and the learning effectiveness by identifying at-risk students and provide them a timely intervention. This is defined by in my talk and the following special issues. So precision education can be implemented in 4 steps: diagnosis, prediction, treatment, and prevention. So as you know, the precision education is inspired by precision medicine, which is an initiative proposed by President Obama in 2015. It's a great effort to revolutionize how we improve health and treat disease. And in fact, precision medicine right now is the mainstream of medical education and also the medical field. So the precision education is trying to solve the problem of a one-size-fits-all approach. So the precision education bears the same ideas. Try to in education, we also have the problem of one-size-fits-all. So we try to find their individual difference in students. This is a comparison between medicine and education. So our main target is to find out at-risk students, just like medicine is, precision medicine is to try to treat disease. And so the other question is about the research goal and the steps. So from my previous description, the research goal is to identify at-risk students and provide timely interventions through the 4 steps. So the 4 steps is our main focus in precision education research. The first one is diagnosis. We try to know students' engagement, how their engagement their learning patterns and learning behavior. And then it's a prediction of students' the learning performance. That include the GPA or some formative or summative performance. And then it's a treatment and the prevention with some intervention. In learning, there is no magic pills in learning. So we need to do more intervention through teachers to students. So we're trying to turn our learning and education from one size fits all to one of a kind. So for 1 million students, there should be a 1 million kind of strategy. Okay, this is a quite famous chart I borrow from Gardner. This is a level of data analytics. It's about the descriptive. It's say something what happened. So for the descriptive, and then it's a diagnostic. Diagnostic is why did it happen. Then the predictive is what will happen, and then it's the prescriptive analytics. How can we make it happen? So there are 4 kinds of analytics. So we use matching the 4 steps of precision education with the 4 kinds of diagnostics. So in our research, we have a lot of diagnosis dashboard for descriptive and diagnostic analytics. And I think most of the research is in prediction of students' learning performance. So we also do this. We use, you can use a traditional machine learning or use a deep learning, and I will show you later on. And then it's the treatment with intervention. Sorry, there's some Chinese characters. I forget to translate it. But anyways, this we provide a kind of intervention through provide students some recommendation individually, try to enhance their learning and recover their behavior from misconduct. And we also provide learning strategies. As I said, there's no magic pill. So strategy, especially the learning strategies, is quite important to guide the students from the very beginning.
Thank you, Professor. Could you please explain AI techniques and how they can drive precision education?
Okay. Oh, by the way, you can interrupt me to ask any questions when you pop up.
Yeah.
Okay, this here I briefly introduce the AI techniques we use in the precision education. There are all kinds of algorithm and the training. So we use the machine learning based and the deep learning based AI. Machine learning mainly for use statistics. So we do the prediction, we use machine learning. And because the data set is not that large, for deep learning in general, they have a huge database and a complicated problem. So we, especially in the natural language. So I will show you later on how we did it. And for deep learning, I think all of you know the CNN is for image and sound, and RNN for text and time series. We use RNN, okay, and then the pre-train and the fine-tune NLP. So in our research, education mainly text is processing, text processing. So with NLP, we use a BERT and the GPT-3 or GPT-2. Because the GPT-3 you need to pay for some money in order to use GPT-3. Yeah. So we use the GPT-2. I think you already know BERT. So it's a pre-trained. And how we do the fine-tune? We use a fine-tune. I will show you later on. And this is the GPT-3. We use the generative transformer to generate a certain kind of a question. Okay, so this is the size compared with the GPT-3 and the BERT. And generative means that you just give him some prefix, and they can predict the next word, and then the next word and next word. So finally, they can generate entire stories or articles. But this also causes some problem era of misinformation. That means the information you cannot tell it from truth or false. And this is the latest development of a large language model especially for NLP. And we can see the corpus, the size of corpus. Take a look at the BERT. It's a 340 million text. And then the GPT-3 is up to 175 billion. So it's almost 500 times of BERT. And nowadays, the NVIDIA and the Microsoft, they are developing Megatron turning NLG. It's over 530 billions. So it's 1,000 times of a BERT. So it's quite amazing, the development of natural language. This is from the Gartner Hype Cycle 2020. And we can see here, the generative AI is still rising. It's very innovative and still a hot topic in research. So there have been a lot of NLP application in education. So right now, with the deep learning, so we can reconsider how to apply NLP in education, such as question answering and question generation. The very beginning is question answering. So use NLP, they can answer question. And right now we're doing a question generation and some common sense reasoning or reading comprehension, and do some arithmetics and then translation. And nowadays it's a news article generation. So it's quite amazing, the development of NLP. And so in our research, I will show you some example how we adopt the NLP. So we develop a PY means a Python. So it's a deep fine-tuned training BERT. We use a cargo Python question from Stack Overview to do the fine-tune. And we can use this to automatic generate question and do automatic scoring. So the type of question such as close and the short answer. Well, we can generate multiple choice too. And for the automatic essay grading, so essay is a short story. It's not a very long. So short essay grading is suitable using this kind of NLP. So this is the flow chart. So we take all kinds of teaching material. In our research, you can be a books. Of course, it have to be an electronic book or an article, as a PDF or PowerPoint as our input. Then we can do some finally generate the close and so kind of questions. This is the architecture, use encoder, decoder. And this is how the close look like. So, yeah, this is close. And short answer is, sorry, I forgot to put short answer. So this is a close. Oops. For essay grading, we use CNN and RNN. It's a little bit complicated, but I make it easy. So it's a recurrent convolution neural network. So it's a recurrent CNN, because CNN is good for grading a sentence level structure, and RNN is good for grading a document level coherence. Okay, and this is the training corpus. You can find from this articles. They use research writing tutor. It's a corpus with 900 research articles from 30 academic disciplines. So this be more emphasized on academic paper essay grading. Okay.
Yeah, thank you. Thank you for your comprehensive review on AI. I noticed that in your research, your group used the AI models to predict students' academic performance. Could you please explain how did you do that?
Oh, sure. I will show that in in the following slide. Okay, here is the prediction. As I said, the 4 steps of precision education. The first is diagnosis, then is a prediction. So it is important to predict the students' performance in order to identify which students are at risk. Okay, so we define some the metrics, how to measure it. And we use a system, it's called a book roll. I will show you in the next slide. So we collect data during students' reading. It's online reading. So it's collect 15 features, and we can do auto ranking. So how is behavior, online reading behavior. Then we can measure its quality of marker and memo. I will show you later on. And then in my class, this is an experiment from my class. I request the students to write reports. Before class, it's a preview report, and after class, it's a reflection report. So we also will to measure, to grade the quality of the written report. And all of this, we do it automatically. So we utilize lots of natural language processing. And then it's a paper exam, because in my department, it requires at least 1 times of paper exam. So we in midterm and the final, we will take a paper exam. And this is use human grading. So this is a system we use. It's called a book roll. It's a reading system. So students can read ebooks from this system. And during their reading, we can collect their data. So it's a reading log. The system looks like this. So students can put a bookmark. He can highlight. We call it a marker. Put a marker. It means a highlight. And students can put a memo, such as put annotations. Okay. And there are 15 features. As you can open, close the file, put at the bookmark, at the marker, and delete marker, things so on and so forth. So we use 8 classification method. All this is based on statistics. And of course, you can use another deep learning model, but in our experiment, deep learning won't perform better than conventional classification algorithm because of the data set and the number of features. And all kinds of metrics, as you know, the accurate AUC will be more proper because in the accuracy, because in education, most of the students will pass. In my class, for example, 80% students will pass. So to measure accuracy is not make sense. So we have, for example, I just guess. Okay, so I just guess they pass. I will 80% accuracy. Okay, so we should use a metric of AUC, and this is the result. So based on the 8 algorithms, we have accuracy, precision, F1, and AUC, and LR, the logistic regression, performs the best. Okay, it's over 95% of the AUC. Here you see there is 80 and 20. It's a grading policy, which means that 80% students pass, 20% fail. It's a grading policy. So if we take a 50-50, it means 50% pass, 15% fail. And from here, you can see 80 to 20 grading policy has the best performance. So this is a summary. We take log the students' reading behavior. So we also grade their preview, reflection. So there are 4 kinds of score: log, score, preview, reflection at the midterm. So based on their scores, we do prediction. Here, logistics still the best, and which one is the best? Log. Yeah, log is the best performance. and preview is better than reflection and better than exam, which means students log performance. So it's intangible observation of students' real reading behavior. Is you can make the best prediction. And then it's a preview report. So preview is writing a preview report, or the action of preview is very important, even important than reflection and important than exam. So this is the result of our experiment. And we also find some critical factor affecting the predictive model, so we can improve the prediction. And here we found open, very significant relation with the students' grade. It's quite common. It's a common sense. As many open file, means the students spend more time reading, they should get a better grade. That makes sense. And delete bookmark means student will do reflection. So he add a bookmark, and sometimes later he come back and delete this bookmark, which means probably he add a bookmark because he thinks that's important. But after reading the books, and he find he already understand the materials, so he come back and delete that bookmark. Okay, so it's very significant to the students' grade, academic performance. Also, the change memo is a kind of features reflect how students do the reflection. So I will add some memo, and then I will change, because I will think twice or 3 times, and then I will refine what I wrote. So you will do the change memo. So this is an indicator of reflection. Another important feature is jump. Because some students, he not reading sequentially, he probably will jump to certain idea or certain pages, which he is most interested. So he can jump forward and also jump backward. So this kind of features we think is a critical factor affecting our prediction model. And this is one screenshot. We have many kinds of screenshot. We can use a signal, like a traffic signals, to indicate pass or fail. And this is used chronicle. So the x-axis is the time. So during the first week, second week, we predict students. Green means pass. Red means fail. So this is students in the very, or almost 2/3 of the semester is a prediction is fail. And in the final 4 weeks, he finally passed. Because of we already do something. Most of them is do some intervention. So intervention is very important. Oh, okay. Now comes to question 4.
Yeah. Oh, thank you, Professor. If we develop such a model, how can it benefit teachers and students? And in your last example, I noticed that a student at first his probability is very low, but after some intervention, the students passed the exam finally. So how can it benefit the teachers and students?
Yes, I think it's for teachers, he can know at-risk students as early as possible through the prediction. And what after that? So teachers need to do intervention when he identify certain students who have a difficulty of reading or study. So this is what we concern. So as a teacher, how to evaluate his quality of teaching. It is a reflection of how good students is studying. So teachers need to know students' issue of concern, okay? And how students struggle with particular topics. So the teachers know his or her students are struggling with certain topics. And teachers also need to know how his slide or his teaching content being used, and also tailor. After knowing that, you can tailor to students the level of understanding, and then they adapt is the way of his teaching. So here is some diagnostic or dashboard information to help teachers understand how his slide, just like I'm presenting a slide. So how his slide being used. For the x-axis is the page. So there are a couple of pages in a slide. So we can see the 5th page have the highest number of events. So teacher can know lots of activity occurred in this page. Okay. So what kind of activity right now he have no idea, but we will dig into. So there are a couple of 10 pages, and most number of markers. Markers means we do highlight. So in page number 4, there are the most number of highlights, so, which means the students put a lot of highlight in this page, which means students probably they think this page reveal lots of important concept or key concept. So they will put highlight in this page. Or students are struggling. They don't know the content, or they need more help from this content. So they will put highlight to ask questions, things like that. And this is the marker quality. As I say, we request the students to, in my class, I request the students, they have to put highlight, which means you put markers. So how good is the marker? That means the marker qualities. So take this page as the example. Here, 0.41. So the quality of a quality means that did the students mark the important key issue or key words instead of highlight whole sentence. So there is another research. The frequency of markers is not positive correlated to students' performance. Okay. And this one is memo quality. It's like writing annotations. So how good students write written skill, we can measure from this marker quality and memo quality. So both of the quality evaluation, we use the natural language to calculate. And here is to enable students to take control of their own learning. So it's quite important to let students can compare with his peer students to know his position in his class. Okay, so this is some dashboard. So this means a student, he can know his position in a class. Okay, take this event. So it's the event counts. So it do online reading. So the number of event. Okay, the green line is the student. Yellow line is the average. So for these students, he performed pretty much about the average. And here is the use a pie chart to indicate its performance. Okay, so take this one. For if a student who is the red, it has the most event. And we also use a heat map. So basically this pie chart or heat map to let students understand his position in his class. Okay, now your turn.
Hello. Thank you, Professor. But we know that a big problem of AI is that the bias in dataset and the models. So when we are doing such research, how can we do it to eliminate the bias and protect students?
Yeah, thank you. I really like this question. So before this question, fifth and the sixth, most of them are my previous research. So after this is my recent research. It's about the AI ethics. We know the bias, so how to eliminate the bias and how to prevent the misuse of AI. We can treat AI as the twofold. One is the enabler. So it will enable human kinds of welfare. So let our living make better, such as improve the productivity of our food, health, water, education, and so on. And it also can help to the resource management about our circular economics and the smart cities. All these kinds of all depends on the AI technologies. And also the autonomous vehicles is typical AI application. And right now it's about the renewable energies and how to use smart gridding to do the smart management, because we know sun is not always shining, right? So when during the night we don't have solar energies, so the smart grid need to switch automatically and very smartly to other energy source. So this kind of a smart grid right now is almost depends on the AI technology. But on the other hand, AI could be an inhibitors. So enable us to do the good things, also could inhibit us from something not good, such as a misuse of AI. Here is an example misuse of AI. If our government put citizen scores on every citizen, then it's a misuse of AI. Even face recognition is a misuse of AI because it will challenge our privacy. The privacy is very important in, I believe in Australia, it's the same thing. In Taiwan, it's the same thing.
Yeah, it's very important.
Yeah. It's very important. So you can imagine if we, as a human, we've been marked with a score. So if your score is higher than me, what that means? It's weird, right? It's very weird. Yeah, so it's a human right. At least when we're using AI, we should avoid this kind of things. And because it could be a misuse of AI. I'm not saying it definitely is a misuse, but it could be a misuse of AI. And for the social media, it's also the same thing. You know, social media, they will, will do some partition specifically suit to some preconceived ideas. So as for example, I prefer education. So all the information I got is about education, and I won't be able to see some other or some negative or even opposite to my opinion. So this could lead to, we say, the political polarization. Okay, so for take example, America, they have two parties. So one party will never see positive of the others. So they will fight each other. So I don't think that's good and not the purpose of AI. Okay, and we also affect the social cohesion. And as you know, the algorithm will have bias because it's trained from the regular news article or internet articles, and because of our human society and our cultures, we have some stereotype, especially we so-called societal biases against the woman and minority. Okay, that's we try to prevent, but it's just happened, especially for the training, the data set, most of them from Western side, right? So it's a training is based on Western civilization, based on their perspective, not from Eastern, right? So especially from American opinion. So most of the algorithm trend is based on American perspectives. instead of Chinese perspective. Okay, this could have many societal biases. So things need to be changed. And the other is the gender and the racial inequalities. It's been there for a long time in our societies, and right now it's inherited to AI because of the training data set. And here is the last year's Gartner hype. See, the digital ethics is important. And also they do the responsible AI and human-centered AI. And human-centered AI is my current research. Okay, yeah. So right now we face some challenges.
Yeah. Right now we are facing some challenges for using AI in education. This kind of research relies on multidisciplinary collaborations. What is the current state of the collaboration? What challenges are we faced with? And the recent years have witnessed the quick development of online learning. Would it bring about more opportunities and challenges to AI in education?
Yes. The challenge ahead is right now it's definitely multidisciplinary collaborations from different disciplines. For example, we as a computer scientist, we need to work with educational, and right now with the sustainable SDG, sustainable development. So we need to work with scientists from earth science, from climate change, from water, okay, even from social society, social science. Okay, so different disciplines need to work together to solve the problems we are facing. As I addressed before, the bias, the misuse, the misconduct, okay, or even the bad result because of AI. So we need to solve those kind of problems. We need different discipline scientists and workers to work together. So that's the first question. And for the online learning, if we take online learning as a default, okay, especially in COVID-19, okay, what been changed because of COVID-19 is a resilience education. Okay, so that I will talk about that later. So I put here the answer is sustainable education. Okay, so here this is my latest research. I work with different disciplined scientists. So first, let's look at in SDG. Okay, SDG, the number 4 is the quality education. So quality education considering humanities, I think that will be a sustainable education. So what's the value of humanities? We need to, as a human, right? We need to take care seriously the fairness and the equities. As a human, it's our human right. Diversity and inclusion. We have different race, genders. There's lots of diversity, and we need to include them. It's inclusion, and we need to be responsible and trustworthy to everyone. So this is the basic value. And what the challenge as you address? So there must be a kind of challenge before. I put together them. I call it the ESG education. So the challenge comes from the educational, from the social, and from the governance. So we need to take care of all the stakeholders. Here is a more precise of what I'm saying. We know ESG is mainly from ESG is from UN. I recall it's probably I forget the years, but it's mainly to regulate. It's kind of regulate the enterprise to fulfill their responsibility to our environment, especially to our Earth. Enterprise need to take their responsibility. So the ESG emphasizes on environment, social, and governance. And right now we emphasize on education. So I replaced the first environmental with the education. So we need to dig into the pedagogy, technology, and practice. Consider the school, family, and government policies, and also the resilience and the robustness. And for the social, the three humanity values as I addressed, and then the governance. Okay, in educational perspective, the resilience. Resilience means we can recover from a sudden and dramatic change, such as earthquake, okay, or the COVID-19. Okay, so the resilient education is right now we are working on. We need to make our education system as resilient as possible, not being interrupted or being destroyed due to the chaos or dramatic change. I believe we all experienced the past 2 years of COVID-19, and we already find out some way to continue our research or our learning. Just like today, we are through the online interview, right? Okay, so it's a kind of, through technical robustness and the safety of network. So it's very important, network and the devices have to be robustness and the safety. And then it's the adaptation and accessibility of teacher. You know, the resilient education, the main problem is the availability of teachers. So when students are online, you cannot expect, elementary school students, they automatically know how to the active learning or self-paced learning. They don't know that. They still need good teachers for their guidance. So it's quite important for the accessibility of teachers. And as a teachers, you need to do some adaptation. Okay, so it's not a face-to-face, not in person. Instead, right now we are through the terminal. So how to make some adaptation mentally and physically is quite a challenge to teachers, all kinds of teachers. Okay, so this is what I mean, a resilient education. And here are some design principles. I skip the design principles, and I will email you my presentation after our interview, so you can have.
That would be nice. And when they watch the recording, they can just stop and watch the slide.
Today is only a kickoff our conversation.
Yeah.
I will send you my presentation, and then after you read, we can continue conversation. That
should be very nice. Oh.
Okay, great. I love that.
Yeah.
Okay. So I skip this principle, okay? And here is another principle. Okay, right now, let's take a look at fairness and equities. Okay, it's an important value, right? So fairness means our analysis technology must produce fair result, but for many AI algorithms, the result is not fair because of the bias of data set, right? So we need some bias prevention algorithm, okay? So here is the method of bias detection. This already a lot of papers investigate how to avoid bias. So before that, you need to detect, right? So pre-process, they classify it into a pre-process, in-process, and a post-process. So before the algorithm process data or pre-process, you need to remove the bias. So how to define bias, right? And they use the word occurrence, so to eliminate the bias words. Some kind of words is very biased. I didn't put that slide. They have statistics about the bias, some saying will say male is lazy. is a kind of bias, you know.
Oh, I don't know that, but
anyway.
I know I know there are like some 20 or more than 20 definitions of bias in math.
Right.
Yeah.
There's lots of bias. Yeah.
Yeah.
Okay. Or some sensitive features due to cultures. Okay. So Western and Eastern, we have different cultures. So some saying we don't like it. As a Chinese, we probably don't like it. But for Americans, they think that's a joke. It's okay, but it's not the case, right? Also, in contrast, our joking probably in Western side they don't like that. Okay, so it's a sensitive features. We need to take care of that. So in process, they have a fairness optimization, use the cost function. So if identify a bias, then it will give some penalties, things like that. And this is post-processing, some principle. Okay, I skip this. And here is the diversity and the inclusion. I will say this, the sentence is, our inclusion means, first of all, it needs to be diversity. All kinds of, we can include, and the equal. It must be have the equal opportunities. And the most important is the belonging. Okay, so once we include people, various gender and various age, okay, or men and women, we have to let them learn and know their belonging, okay, so that they can feel they belong to this group, these communities, and they can bring their home self to learning and inspire to learn. Just like our conversation, I already include you and you already include me, right? This kind of inclusion. So yeah, so inclusion will brings belonging, right? So we will feel today's interview and our conversation belonging to each other. So that's very important in the social issues. And then is the trust. Okay, I believe you know the explainability. I use this. Okay, right now AI need to be explainable. Okay, it need to be transparency. Both in the data set and the algorithm need to be transparency. Okay, and this is XAI. So all kinds of XAI try to extend its explainability in deep learning and traditional machine learning. I know in deep learning is difficult because of too many layers of a neural net. It's very difficult to do. Yeah. And for machine learning, I do see some example, especially use forest. You know, as a SHAP, S-H-A-P.
Yeah, SHAP. Yeah. It's from game theory. I once learned about that. Yeah.
One of our research use SHAP.
Oh yeah, I noticed that. SHAP plot. Yeah.
Okay. All right. So here are some challenges. Your turn.
Sorry, I forgot to unmute myself. What are other challenges that AI is faced with in education? Okay.
This challenge, I recall I used the same materials as my 2018, before 2019, my presentation on ICCE, I have a talk in Kyoto University. So at that time, I first mentioned the new challenges in education. I will go through one by one. The first is we will, from general purpose to transferring. You recall, in very beginning, we tried to find a universal solution to solve problem we think that should be common sense. But right now, we use the transfer learning, like fine-tune and pre-train and fine-tune. This kind of methods is transfer learning. So transfer from one domain to another. And we also transform from computational thinking to cognitive thinking. So computation thinking is make human to mimic computing, right? But right now, is a deep learning algorithm. Those algorithms are mimic humans' perception. So it's a cognitive thinking instead of computational thinking. And customization to adaptation. In our previous application is beforehand. So beforehand means we can predict in advance and do something later. But right now we need to do it real time. So it's very difficult to do real time. It's like an autonomous vehicle, okay? And this is more philosophy. Is in general, we knowing what we don't know, okay? So we try to figure out, try to find the reason, find the insight, because we already know what we don't know. But the problem is the other. We don't know what we don't know. Okay, so it's quite philosophy. So we try to use AI to dig in or find out the hidden value. Hidden value is I have no idea what is hidden value, but AI can find it for me, or some unknown results. Okay, so this is very difficult, and this is the our precision education. So from one size fits all to precision, and then it's from technology to humanity. As I addressed the sustainable education or human-centered AI, we consider humanity in the first place. Okay, here's the future.
Yeah, in the final part, let's imagine the future about AI and education. What can the government do to support and regularize precision medicine education? As a major concern, what will be the relationship of AI and human teachers in the future? As computer scientists and engineers, what can we do to support the development of precision education?
Yes, okay. Well, I like the question. I used to work in government in Ministry of Education. It's around 10 years ago. So I know the government policy is very important. So as a scholar, we need to do research and try to make it as a policy and feedback to our government in order to help our government to do something good or do something right. So it's our job. So that's what I'm doing with my colleagues. Okay, and how to also apply AI to change to change the way of teaching. Okay, so what we have done, we are doing for sustainable education, or for ESG, or for SDG. As a university scholars, writing paper is most important. So I write a special issue on precision education to promote this idea. And this journal is 2021. Okay, I've been the guest editor. And then I write a position paper, also the 2021, with my colleague from Japan. We addressed human-centered artificial intelligence in education. So this position paper also led us to another special issue, also in the MIGA. Oh, by the way, yeah. MIGA is your co-advisor, right? MIGA Chen. Okay, the ETNS. So we have a special issue. It's going to, right now it's online. All the paper been decided and will officially published next year. The human-centered AI in education, co-guest editor by me and Hiroaki Ogata. You know him? Ogata, Professor Ogata.
Oh, sorry, I didn't know him.
Okay, next time I can introduce you to him.
Yeah. Oh, thank you.
From Kyoto University. You know Kyoto University?
Oh, yeah. I know that.
Chinese, you know, Jingdu Daxue.
Yeah, very, very famous.
Yeah, very, it's famous by its Nobel laureate. It has the most Nobel Prize winners in Japan. Even in Asia, it's #1, Kyoto University. Yeah. And then is the Matsui. Matsui is a Waseda University, 早稻田. Waseda University.
Yeah, also a famous Japanese university.
Yeah, very good university. So, yeah, next time I can introduce you to them.
Wow, we can another interview.
They are very nice guy. Yeah, very nice guy. Okay, for the as I address the work with government, we from NGO try to affect our government. So there is the largest NGO in the world for scientists, researchers, most of them from natural science. Okay, the organization, the name of the NGO is Future Earth, and there is a branch in Taipei, in Academia Sinica. Okay, you know Academia Sinica? They have a similar organization in China. This is the highest academic institute.
I think it should. I think there should be in the mainland. Yeah.
In mainland China, it says 中国科学院.
Oh, yeah.
Yeah, 中科院.中科院. A similar position is the highest rank of the academic institute. This one in Taiwan. Yeah, it's directly. So we have a sustainability in the digital working group. Okay, so this one is all the academicians， 就是院士，中研院院士，就像你们的那个
the highest position.
The highest position, the top scientist. Yeah. So under that, we try to held a series of the webinars and try to make impact in some making some policies and suggestion to our government. Okay, through this kind of institute. So this is the webinar we've been held, the sustainable education and also sustainable finance. You know, I can talk about finance. Interesting. I can say education and interest. And this is for the climate change. Okay. And you can recognize. So it's from a human center from Eastern perspective to tell the difference from Western side. And the humanities, and this is important workshop for sustainability research and innovation. Oh, this is the most important conference in learning analytics, LAC. Okay. Will be held in next year. Will be in the United States. This one is 2024 in Kyoto. So you are welcome to submit paper.
Oh yeah, if I can write one.
Yeah, no problem. You can do it. Oh, this is the ESG project. We work with applied materials. You know that's American companies. We do some rating prediction. So use the natural language to read their documents and then make a prediction about their ESG rating. And this is the partnership, because the SDG, the number 17 is the partnership. So we have a strong relationship with Kyoto University. So this partnership is, we call it the BRPT, the Book Road Partnership Taiwan. And right now there are 32 university, 84 teachers in Taiwan participating in this partnership. Okay, so that's my presentation and my answer to all of your questions.
Well, Prof. Yang, thank you very much. Thank you very much for your valuable comments and thoughts today. And we have to end today's interview. Thank you again for your coming.
Okay, thank you. So see you next time.
Yeah, see you next time.